Hello, welcome back to the channel. We're continuing the video series dedicated to the high-level overview of the Site Planning and Design Handbook. This video is about Chapter 3, and that is Site Data and Analysis. Site analysis is one of the most important steps in the successful site design process. The purposes of site analysis are to gather data for preliminary planning, evaluate the site for compatibility with the project or use, recognize concerns requiring additional study, and form an understanding of the administrative requirements of the project, such as required permits and approvals. A site analysis is a critical first step in planning and designing a site, but too often the value of a thorough evaluation of the site is discounted for the sake of lower costs or shorter timeframes. Discovering site limitations or issues further into the planning and design process can be an expensive lesson. If such issues are discovered after design or when construction already commenced, the cost can be significant in economic terms and devastating to one's professional reputation. So the site designer rarely has the resources or time to complete a comprehensive site investigation on speculation of winning work. Therefore, site analysis are usually conducted in two steps: a proposal phase to facilitate winning the work and a post-contract phase. The proposal phase site analysis is extremely important because the proposal, sometimes even including preliminary design and costs, will be based on its outcome. As in-house resources provided for the assessment are usually limited, it's important that they are used carefully. The cost of collecting physical information at this stage of a project may be problematic, so other sources of information must be found. Site characterization is a more detailed site investigation that is usually undertaken after some degree of preliminary site planning. Site characterization generally includes a geotechnical analysis of subsurface conditions such as depth to bedrock, depth to groundwater, seasonal high water table, and specific soil tests. ASTM, or the American Society of Testing and Materials, has developed a standard guide to site characterization for engineering, design, and construction purposes, D420. This guide provides the site designer with a consensus standard with which to plan and evaluate site characterizations. Let's talk about location. The first consideration of the site analysis is to locate the site. Site location entails more than simply locating the site on the map. Commercial projects are concerned about visibility, site access, and traffic. Residential projects have different concerns. For example, schools, government services, shopping, how far are they from the property? Are local roads and streets adequate to handle increased traffic? And also, what will zoning allow, and other concerns as well. When you collect site information, site analysis is an interpretive process. A broad area of information is collected from limited individual sets of information, and these data sets are combined to project a future use of land. Preliminary site assessments are based on precious little new information. That is, much of the analysis is based on existing sources of information of first-hand observation. Site analysis is not done in a vacuum. The context of the proposed use frames the scope and character of the effort. Topography. USGS, or the United States Geological Survey, is a valuable source of topographic information. A local selection of the 7.5-minute quadrangle series of topographic maps is found in every design office. And also they can be retrieved from the website usgs.gov. The most basic element of site analysis is the lay of the land. The topography of a site may dictate the purposes for which the site may be used and eventually the layout of the proposed project. The preliminary analysis of the site provides an early look at how the proposed development will fit into the site. Will significant earthwork be necessary? Will retaining walls or other appurtenances be required? Can the site be accessed from adjacent roads? Is there visibility into the site from adjacent roads? A slope analysis is done to identify the areas of steep slopes and the possible location for building sites and access. Slope analysis is usually a graphic representation of slope shown in classes or ranges. Ranges sometimes established by local ordinances which describe the parameters to be observed when conducting a slope analysis and steep slope development restrictions. From a hillside, the long views are generally considered the most valuable. A site analysis should include identification of the long views and any obstructions or limitations to them. Undesirable views should also be identified and addressed in the analysis. The approach to the site and the actual means of access onto the site are key elements. The best path of circulation, the minimization of impact on the site to develop these networks, and the extent of required cuts and fills are all must be considered. Other elements of the site analysis include the identification of canyons, wetlands, rock outcroppings, existing structures, unique habitats of natural features, neighboring land uses, and utility locations. Flat and low areas present their own concerns. Findings of the site analysis may indicate that further research or study is required to determine the stability of slopes, hydrologic conditions, or the extent of wetlands. In addition to topographic maps, USGS can provide aerial photographs, digital orthophoto quadrangles, and other high-quality sources of site data. And a number of websites offer free aerial photography. So, for example, through the Center of Integration of Natural Disaster Information, the USGS has a greater deal of information about regional and local site hazards such as earthquakes, landslide risks, groundwater conditions, flood risks, and many more. Let's take a look at the USDA plant hardiness zones. The USDA updated the plant hardiness zone map, so familiar to growers and planners, in 1990 and reformatted the map in 1998. The new version incorporates new temperature information by using coldest weather data from the years 1970 to 1986. The map introduces a new zone, Zone 11, which is essentially frost-free zone. Discussion of the plant hardiness zone map is included in this in the zone analysis. So it is estimated that warming trends may have significant impacts over the next 100 years, with notable changes occurring by 2025. These changes may significantly affect the performance of designs under consideration. FEMA maps. The Federal Emergency Management Agency, or FEMA, is best known for the flood maps it has published over the years. Just as the USGS is more than topographic maps, FEMA provides much more to the site analysis process than flood information. FEMA maintains a website that allows the designer to create a fairly site-specific map of hazards related to earthquake, tornadoes, wind, and hail, as well as floods. you can go to the FEMA's website. It's FEMA.gov, and that includes a number of valuable links for the design professionals. So FEMA provides information on changes to the existing maps on the website. So always please check back. Vegetation. An assessment of existing vegetation may tell a designer a great deal about the site. Evidence of second growth vegetation is an indication of past activities that should be reconciled by the analyst with other sources of information. The quality of vegetation is also an important consideration. Quality specimens of trees or valuable population of another type of plant should be protected or incorporated into a future design. Trees or tree masses may contribute value to the finished project, and their location must be considered in the assessment. Mature trees are known to increase the market value of property, and a qualified arborist should be asked to assess the condition of specimen trees to determine their relative value. Please refer to the textbook. You can see Urban's tree condition methodology. So it has 7 conditions, and it starts from excellent, then goes to good, fair, poor, very poor, replace, or dead. So, and then there is a description for all those conditions. So please refer to the textbook. Aerial photogrammetry. That provides an accurate mapping of topographic and physiographic features using low-level aerial photography. The topography is interpolated from limited topographic data collected on the ground. Properly prepared photogrammetry meets national map accuracy standards and may be significantly less expensive than traditional field topographic methods, especially on large projects or projects with significant topographic variation on many features. Historical aerial photography. Private firms may have generations of aerial photography taken on speculation or on contract. Many communities also have collected aerial photography over the years. Some state geological surveys and the USGS also have historic aerial photography available for purchase. The American Society for Testing and Materials, or ASTM, has developed a standard guide for acquisition of file aerial photography and imagery for establishing historic site use and surface conditions. That's ASTM D5518-94E1. Public sources of photography are helpful, but many private sources exist as well. Photography firms may be reluctant to enlarge photography to the scales useful for site planners because of the inherent distortion and inaccuracy that can be anticipated in the resultant print. But these enlarged photos are a valuable planning and analysis tool. USDA Soil Survey. Those surveys have really a lot of valuable information. Soils are classified as serious, and these types are further refined into detailed soil map units. The soil descriptions include information on slope, depth to bedrock, soil texture, erodibility, rock, and other important factors. So, although soil borings and test pits may be done eventually, the site analysis may use existing sources of information such as the local soil survey or previous soil analysis. Each local soil survey includes a description of how the survey was made and how to read the survey as well. So please refer to the textbook. Always back up my videos with the textbook. You can see images and diagrams and some aerial photography here. And we are continuing with the hazardous soil conditions. So, for example, expansive soils occur in every state, and these soils may cause extensive cracking of sidewalks, foundation failures, retaining wall failure, and so on. Liquefaction, a condition in which solid ground can turn mushy when soils are vibrated, is associated with earthquakes. Under certain conditions, soils lose all bearing capacity. Buildings or bridges can slip or sink like quicksand, and buried structures can float to the surface like tanks. These conditions have been associated with fine to medium grained sands and silts found in loosely packed layers. The greater the soil density, the lower the factor risk. A clay content of 15% or more is adequate protection from liquefaction. Another form of liquefaction is found in quick clays, which can become quick or liquefy. Confined to the northern states and Canada, these very fine flour-like clays are formed as sediments in shallow waters and raised above sea level. Collapse of quick clays has been associated with high water content. As the material weight exceeds its shear strength, slope failure results. And again, please refer to the images here in the textbook. Let's talk about hydrology. The presence of water on the site and the general pattern of drainage are key concerns of the site analysis. Water is often the key feature on the site. Waterfront brings added value, but it also raises concerns for development. The presence of a surface water feature may be coincidental with a fairly high water table or shallow geological features. Drainage patterns should be carefully observed in the field as well as being examined in published sources of information. It is important to locate and identify springs and seeps in the site analysis process. Very often, these features are located on USGS maps or soil surveys, but the analyst should confirm their presence in the field. And again, please refer to the images. You can see the USDA soil survey map and other graphics. The site analyst should consider the sensitivity of hydrologic features to development. Erosion and sedimentation during and after construction may represent a serious threat to surface water quality and habitat. If significant measures will be required to protect surface waters, these should be discussed with the site analysis. Determine whether receiving waters are high quality or restricted and how their status might affect the project. So again, please refer to the chart. You can see the recognition of expansive soils in the field. Local records and history. Land use planning and development is generally an issue and a concern for local government. Local governments very often have substantial information about the site. As discussed in preceding sections, here in the previous videos, we discussed that aerial photography, mapping, and other physiographic information is often available from local governments. So let's take a look at the zoning. Zoning regulations provide a prescription for how development is to be done in a community. The general conditions of development are described in terms of what development is encouraged and where in the community it will be. Zoning maps provide an overview of the community's vision for itself, not only indicating how a site may be developed or used, but also how surrounding sites might be used. Zoning regulations may contain design criteria such as parking configuration, lot sizes, setbacks, road width, road profile restrictions, and sign requirements. Zoning ordinances restrict development by providing the limits and conditions of development, but they facilitate development by providing developers with a guidance document. Occasional zoning may include overlay zones and have important implications for land use. Overlay zones such as steep slope restrictions, watershed protection, historic preservation, or aquifer protection may severely limit land development activities or require a high order of performance from the design, construction, and operation of a site. Let's take a look at the land development regulations. The scope of land development regulations varies from site to site and from state to state. Land development regulations typically include requirements for local street design, open space, lighting, subdivision standards, minimum landscaping, and similar site development parameters. Zoning requirements of initial concern include the permitted uses, density, minimum lot sizes, setbacks, and open space. Some zoning ordinances require special setbacks between different types of uses, such as a buffer area between residential and commercial land uses. The requirement for buffers, screening, and open space should be noted. Utility mapping. Location of utilities is made possible using maps provided by local utility companies. Increased use of geographic information systems has helped to provide reasonably accurate utility data in most places. However, utility maps generally are not considered accurate, and locations should be confirmed in the field for design purposes. And we're moving to the historical value. Identification of historic and archaeological elements is very important because most states have regulations protecting historic and archaeological materials and sites. Discovering that a site has a historical feature or value is a critical piece of data in the early analysis. Sources of information regarding these features include local and state historical agencies and societies, local government records, USGS maps, and libraries. Place and road names can provide insight into former conditions and uses as well. For example, a site located on Swamp Road could suggest seasonal flooding or wetland conditions, not in evidence at the time of a site visit. Also, local historic and cultural values, sometimes hard to discern. Written information may address the physical area of value, but not address the community's attachment or less tangible values such as views or local character. These values are often unwritten and informal, but they may represent a significant unofficial community interest that should be addressed. Infrastructure. The location of surface and subsurface utilities is part of the site analysis as well. The analyst should identify the location, capacity, and access for all necessary utilities, as well as the requirements for connections. Access to public water and sewer should be evaluated. The capacity of existing water and sewer may be of concern in some communities and should be evaluated at an early stage. Let's move to the next subsection of Chapter 3, and that is access and fit. Fit is difficult to define, but like quality, you'll recognize it when you see it. In some places, fit is as simple as reading the zoning and local development plans. In other communities, assessing fit is more difficult. In general, fit is determined by how the project design and function fits into local zoning, land development plans, physical aspects of the site itself, the neighborhood, occasionally the region, and with the values and needs of the community itself. So when we take a look at the program requirements, we see that it's necessary to have an understanding of the proposed project when conducting the site analysis. In most cases, the designer must rely on the client and experience to form a working understanding of the proposed project. The analysis must consider the fundamental elements of a given project, such as the site of proposed buildings, access to and from the site, lot layout, parking requirements, vehicular and pedestrian circulation, and the general strategy for storm water management. Site analysis should extend their efforts to consider off-site issues as well, which may include traffic issues, local flood or storm water concerns, or infrastructure issues. Permitting and administrative requirements are particularly important in contemporary site development. Knowing which permits are necessary and the expected lead time required is often a critical element in a project. ADA and pedestrian access. The Americans with Disabilities Act, or ADA, became law in the US in 1990. Under the Act, a person with a disability is entitled to the same access and accommodations as the public in general. As a result, buildings and site owners were required to remove barriers wherever such an accommodation was considered readily achievable. The readily achievable test can be ambiguous for existing buildings, but for new construction, it is clear that all public accessible designs must incorporate ADA principles and requirements. The Americans with Disabilities Act accessibility guidelines were promulgated by the Architectural and Transportation Barriers Compliance Board. These guidelines are available on the website. It's adaag.org. Although many of the design conventions of ADA have become commonplace, site designers may want to consider forming a preliminary analysis of the accessibility issues that may be encountered. It is recommended that designers confirm standards with an updated government resource. Proposed changes to some of the ADA site standards have been made public for comment, but were not yet approved at the time of this textbook. So please always refer to the most up-to-date information, because here in this video, we are reviewing the second edition of the Site Planning and Design Handbook. Community standards and expectations. They're usually unwritten and often ambiguous, but they can be very important considerations in the site analysis. Site designers may intuitively be able to assess the expectations of a community by observing what has been accepted in the past. For example, what does the community and neighborhood around the site look like? Or, for example, anticipating and addressing these expectations in the early phases of design may contribute significantly to the project's acceptance by the community. So let's talk about the environmental concerns. And a site analysis and the analyst should be aware of conditions that may indicate environmental contamination. Another environmental aspect of growing concern to site designers is the impact of environmental trends such as global climate change and its anticipated impacts, and the growing demand to incorporate sustainability into site development. In particular, site designers working in coastal areas subject to tidal influence or in areas with important hydrologic characteristics such as wetlands or cold water fisheries may wish to consider the anticipated impacts. Beyond these concerns is a need for a deeper understanding of what the site does systematically in the environment, and that is part of a larger landscape. Here, please refer to the ecological services analysis. There is a chart showing important information such as identification of vegetative communities, then habitat, seasonal and year-round, then presence of colonial birds, hydrology, soils, local climate, windbreaks, and so on. So when we talk about environmental site assessment, we need to understand that today real estate buyers and almost all the lenders require an environmental site assessment or ESA of a property before committing to a purchase. An ESA is a risk assessment used in the planning and feasibility stages of real estate development. Assessments are used to evaluate all types of properties for conditions that are indicative of possible environmental contamination. Lenders want to limit their exposure to lawsuits and liability for cleanup responsibilities and will demand full disclosure of any known contaminants or conditions. The information in the site assessment report should identify any recognized environmental contamination and describe what further steps might be required. The most common and widely accepted site assessment protocol are those developed by ASTM. These consensus standards are developed by practitioners and users of ESA. The Standing ASTM Committee meets periodically to consider and occasionally revise the standard guidelines to reflect current practice. So when the site assessment is performed, under the Federal Comprehensive Environmental Response Compensation and Liability Act, a landowner is liable for the environmental conditions on the site, whether the individual or company had any knowledge or involvement in causing the condition. This liability can include the cost of cleanup as well as damages to third parties. The Small Business Revitalization Act has given some important relief for landowners, but caution is still advised when purchasing property. And here, please refer to the textbook. You can see ASTM standards for site assessment, and there is a number of them. You don't need to memorize them, but you need to know where to find the information. So when we talk about the format of a site assessment, typically a transaction screen and a phase 1 environmental site assessment should be conducted before title is transferred. The phase 1 environmental site assessment requires the services of an environmental professional. A transaction screen may be performed by a person with knowledge of land and real estate, and a site design professional has adequate knowledge to conduct this analysis. Very often, lenders require a phase 1 environmental site assessment as a minimum acceptable level of investigation, and the transaction screen may be used to provide guidance. Here, for example, ASTM Transaction Screen and Guide, or E1528, is the most commonly used format. Again, there is a chart of level of inquiry for an environmental screening. Please refer to the textbook. Several factors contribute to deciding to perform a phase 1 environmental site assessment. First, if the buyer is a professional developer or a person familiar with real estate, it's likely that the buyer would be held to a higher standard of inquiry than a simple home buyer. Second, if a site has been used for industrial or commercial activities, it should be assumed that there is a greater chance that hazardous materials may have been used or stored on the property. This increased risk should compel a greater level of inquiry. And third, many lenders require a phase 1 environmental site assessment as a minimum level of inquiry. The ASTM standard practice for environmental site assessments are Phase 1 environmental site assessment that provides clear guidance with which to undertake the ESA, but also allows for the exercise of judgment and discretion by the environmental professional. The Phase 1 ESA is designed in principle to be a cost-effective overview of a site that should identify indications of recognized environmental conditions. To keep the cost of the investigation at a reasonable level, the typical Phase 1 ESA involves no collection or testing of samples and is limited to information already available through public sources, such as interviews or first-hand observation. This approach allows the buyer to determine whether there is an indication of a problem or an increased risk with a particular property. The ESA report should include copies of the notes collected during interviews, the database review summaries, maps, aerial photos, and other documentation. And here again, refer to the checklist, site analysis checklist that has administrative issues. So it's quite a long list, so please make sure you get familiar with that. We're moving to the final subsection of chapter 3, and that is brownfields. So what are the brownfields? They are abandoned or underutilized properties that are environmentally contaminated or are perceived as being contaminated from past industrial or commercial activities. Such sites may present a designer with a excuse me, wide range of unfamiliar site restrictions and conditions. Site planning on such sites must address the contamination or the mitigation strategies selected to protect the users and the environment. Normal practices of site development and stormwater management may be restricted. So to be effective participants in a brownfield mitigation process, landscape architects and site engineers should be conversant with the environmental professionals and understand the value and limitations of the site assessment process. And again, please refer to the textbook. You can see Phase 1 ESA Quality Assurance Review. There's a long list, and you need to understand what to include on the report and the site walkover. So knowledge of the state of practice and site remediation technologies will increase the opportunity for collaboration in innovative site design, enabling site designers to work closely with environmental professionals in the interest of the client and the environment. So that was it for chapter 3. Thank you so much for watching. I will see you in chapter 4. Thank you.